Okay, in this first example, a 50 kilogram box is being pulled horizontally across a floor with a frictional force of 15 newtons that opposes the motion. A. Draw a free body diagram showing all the forces acting on the box. And B. What will be the results of the force of the applied frictional force when combined. So you can pause the video for a moment and you guys give it a try. Now to begin with, what we can do is draw the box. So for part A, you draw your 50 kilogram box. Now from here, let's draw a free body diagram. So from the center, so we will consider this from the middle of the box. So you have a force of gravity pulling you down, and since the box is not sinking into the table or floor, you have a normal force, and both of them are equal. You also have a force applied, and you have a frictional force. So that would be enough for part A there. If you want to get the amount of the force of gravity, remember it's mass times gravity, and that will be on Earth, so 9.0 meters per second squared, and 50 times 9.8, and you have a normal force of 490 newtons. Well, since you have two significant digits, 4.9 times 10 to the 2 newtons. And your normal force will be equal to this. So your force normal is equal to your force of gravity. Now your force applied and your force of friction. You're told that a frictional force exists of 15 newtons. Now it's being pulled across the floor. Now we haven't been told otherwise, so we're going to assume constant motion. So the force applied must also be 15 newtons. So the box is being moved across the floor at a constant speed. So your box is here, is being pushed or dragged across the floor at a constant speed. So the force that's applied is just enough to oppose friction. If the object's not speeding up, then the force applied is equal to the force of friction. Okay, now combining forces. All the separate forces that act on an object can be combined, and forces involved. You can have an unbalanced force, and there's a symbol for that, force unbalanced. Your net force is your overall force, or you have the resultant force. So it's three ways of saying the same thing. What's the net force? Force unbalanced making it move, or resultant force. So if you see one of these three, they're asking you to do the same thing. The net force will be a single force which could do the job as all other forces combined. Both size and direction of this force are important. So it's a vector. You got to have size and direction. And later in the unit we'll see the forces can be combined using a scale diagram approach or a mathematical approach. Okay, so there's 4 different cases of combining forces. Let's go here. So 4 cases. And first case. Here's your first scenario. Forces are acting in the same direction. So if you have forces acting in the same direction, then what would happen here? You have force 1 and force 2, both pulling on an object. Force 1 pulls with 120 newtons. Force 2 pulls with 180. Oops. So your force net, or your resultant force, is the addition. This is what I meant by algebraic addition. They just add them simply as you would any other number. So you have 120 newtons plus 80 newtons, and the overall force is 200 newtons. Both are going in the same direction. So if you want to say direction was to the right. And that could be combined, showing just one single force. So pulling with two different forces is same as pulling with one force, force net of 200 newtons to the right. Or you could say to the east, as long as you were indicating a positive direction. Now your second case, well, they can act in opposite directions. So you can have the same direction, you can have opposite directions. And approach it same as you did with the last question. So force net will be your force 1 plus force 2. And when you're doing this, you only consider forces in balance with each other, or in opposite directions, so left, right. So our force 1 is 120 newtons. And we don't have to, we could say right, or we could say to the east, just indicating that positive direction, plus 80 newtons. And this one's not in the same direction, so we could say it's to the west. And when you're adding here, same as we've seen before in Unit 1, you have to have the same direction. So I'm going to keep my biggest number in the same direction, but I want this to change to say east. So I have to change this to a negative 80 newtons. So 120 plus a negative, or you could say 120 subtract 80, will be the same, is 40 newtons to the east. So if you were doing a tug of war, you were pulling with 120, your friend was pulling back with 80, it would be the same as if you had one single force pulling to the east with 40 newtons. Your third case is you have forces that are perpendicular to one another. And if you remember from math, perpendicular would mean that two forces are at 90 degrees. So perpendicular refers to having this 90-degree angle present. So one force is pulling at 80, another force is pulling down at 120. So you do your vector addition here, or same as vector addition. You have one force pulling at 80, another force pulling straight down at 90, so this should be 90 degrees in the middle, or sorry, pulling down at 120. This one's 80, and this is the same as in Unit 1, and you've seen on your last test. Just in the last unit we were dealing with velocities or accelerations, usually velocities, and you would end up having to find the hypotenuse. So your force net in this case will be 80 squared plus 120 squared. Give me a moment, I'll grab my calculator. Alright, so we have 6,400 plus 14,400, 20,800, and when you're doing Pythagoras theorem, remember you have to take the square root. So the resultant force and I want to work that down to significant figures, 1.4. Those numbers 2 digits, so I'll include 2 digits in the answer. Decimal had to move 2 places. Now we also need to know a direction, because this isn't simple left, right, or up, down. So to get your direction here, same as we did in the last chapter, use tan. Tan theta. And we're starting from the center of the object. If you're not wondering which angle to find, this one or that one, well, think back to the center of the object here. And you want to find that angle. So it would be opposite over adjacent. And that can break down to 8 over 12. Divide both, take a 0 out of both. Tan negative 1. 12 over 8. And if you want to break it down further, I mean, you divide both by 4. And put it into the calculator. So 12 divided by 8 is 1.5. And second function tan, you should come back with 56.3. So when you're describing your force net now, it's 1.4 times 10 to the 2 newtons, and direction oops, okay, sorry about that. And for your direction, you're moving east, but you're also being pulled south. So you're moving east, but you're heading 56. We can round that off to 2 numbers, 56 degrees south. So you're trying to head east, trying to be pulled across, but you also have another force pulling you south. Or you could say right and down. Alright, we'll end that part and pick up with one last video.